Hello, ladies and gentlemen. It's time to work on something a little bit different than what we've been doing. What's going on is you're going to be confronted with a puzzling situation. And on this quadratic situations number 0 assignment, we are just setting up the equations that would help us solve these things. We're going to use a variety of methods to solve things in coming assignments, but right now we're just working on modeling what is going on with the equations. And so, let's dive right in here. We're skip number 1. Let's go to number 2 here. We need to find 3 consecutive integers such that the square of the third number plus the product of the first and the second number is a minimum. Woof! That is a lot of math words. That's okay, though. We're going to turn all these mathy words into mathematical expressions that makes an equation. So, first things first, let's talk about 3 consecutive integers. 3 consecutive integers. How do you represent 3 consecutive integers? Well, you can just do something like L, K, and M, right? You could do that. But the issue is, if we use those, we got 3 different variables here. And when we go to solve these later, it's going to be impossible if we only have one equation to solve if there's 3 different variables like this. And so what we're going to do is actually write the other integers in terms of the first one. So if you just pick any old number, like 7 or 6 or whatever, like 12, the one after that, the next consecutive number would be just one more than that. And the one after that would be 2 more than the original one. All right, if you got 7, 8, 9, 8 is 1 more than 7, and 9 is 2 more than 7. And so, but the thing is, the first number could be anything, right? It could be 12, the first number could be 25, and then you have to add 1 to get the next one, and then you have to add 2 to the original one to get the next one. And so we're going to write this using a mathematical expression. Our 3 numbers are going to be just n, or any number, and then you got 1 bigger than that, and then you got 1, 2. You got 1 that's 2 bigger than the original one, or 1 bigger than the one before it. So we got these 3 numbers, some n, and then the next 2 numbers after it. Okay, so that's just the first part, the first 3 consecutive integers. But after you have that figured out, the rest of this turns out to be pretty easy. We got such that, below a colon here, the square of the third number, well, this is our third number, so we're going to write out, we got the square of the third number, so third number squared, plus the product of the first and second numbers. So we're going to plus the product of the first 2. So that's going to be n, and n plus 1. And we're just going to leave it next to each other, so that's going to be multiply. All right, we got those. The product of the first and second numbers is a minimum, equals some sort of minimum. We'll just call it mid for minimum. And that's it. So that's going to be our equation. We have converted all those words into mathematical symbols here. The square of the third number is n plus 2, plus the product of the first and second numbers, which are n and n plus 1, is a minimum. We're just going to write min for minimum. We don't know what the minimum is. If we knew the number, say the minimum number was like -2 or the minimum number was 5, we could put that number there, but we don't know what it is right now. We will learn how to get maximum and minimums later. But for now, this is going to be our equation. Well, let's go down to another one and try this process again. Number 5, a rectangular garden is 50 feet by 36 feet. Part of the garden is removed in order to install a walkway of uniform width around it. The area of the new garden is half the area of the old garden. How wide is the walkway? Woof. Something that helps a lot, especially these like real-ish world kind of ones, is to draw a picture. So just come over here and we're going to draw a picture. We have a rectangular garden. It is 50 feet by 36 feet, if I remember right. Yep. Okay. And they're removing part of it. So it was the whole thing was a garden, but now they're coming in here and adding a sidewalk all the way around. Well, how wide is that sidewalk? How wide is this? Well, it doesn't actually tell us how wide it is. It just says it's uniform. That means it's going to be the same all the way around. So this distance here is going to be the same. This is going to be the same as that. That's also going to be the same. sometimes people don't like using question marks as variables, so let's instead put a variable here. I kind of like the idea of an X or a W. Let's use W because it's the walkway or the sidewalk going around this. And we have this kind of cut into our garden. We're removing that part all the way around. However many feet that is it 1 feet or 2 feet or 3 feet or 4 feet or 5 feet? Not quite sure. Or maybe it's 4.7 feet, whatever. It's some distance there. It says the area of the new garden is half the area of the old garden. Okay. Well, yeah, that might require us to write things out. So we got the area of the old garden. Let's just do A sub old. It's kind of like an indicator. What kind of area are we getting? The old area is just 50 times 36, which gives you a number. And then the area of the new garden is going to be half of that, or 50 times 36 is. Let's actually calculate that. Look at me not being prepared. Don't even have a calculator ready. 50 times 36 is 1,800. And so the area of the new one is half of that, which is going to be 900. Okay, so the inside area here, this is going to be 900 square feet. And then the outside area is 1,800. Okay, cool. And then it's asking how wide is the walkway. We're not actually going to calculate how wide the walkway is, but we're going to set up an equation that helps us get that area. Well, we need an equation that uses these W's somehow. Right now, we know this area is 900, but how do you calculate that area? Well, that area would just be this length here. Oh, that's way too big. Hold on, let me change colors here. That would be this length here times this length here. So if we knew those two lengths, that could equal the 900. And you can actually get those lengths by using our entire length of 36. Oh, not 360. And then we have to take off these two parts here. If we cut those off, cut it off. Well, on the right side, we're just cutting off W. And on the left side, we are also cutting off W. So we're cutting off W twice. So this length here is 36 minus 2W. Okay? And so I'm gonna use that. Here, we'll even do it in red. So we got a side here that's 36 minus 2W. And that's just this base length down here. So this base length here, we're going to times it by this vertical length. Let's do a different color. Let's make it green. This length here is 50, right? That's the whole length here. It was 50. But we have to subtract off the top part, subtract that off, which is W. And then we subtract off the bottom part, which is also W. So it's like subtracting W twice, or just subtract 2W. And so we got the bottom part, and we have the top part, which is 50, minus 2W. And if we times those two things together, it's going to equal the area of the inside, which we already got, which is 900. So it's going to equal 900. All right. This is an equation that we could use to solve for W, find out how wide that walkway is. We got the base length there, which is the 36 minus 2W. And then we got the height part there, which is the 50 minus 2W. And W is just how wide the walkway is. And it's going to multiply. It's going to equal 900. We're not solving this right now, but we are writing the equation. So here's our equation. We got it written out. Okay? So a little bit harder. It helps a lot to draw a picture like, okay, what are the pieces that use our variable that we can use to multiply together to get some unknown value. So is that. We're going to do this one more time, but I want you to see if you can do it yourself. Let's go to number 9. We got Brett. He's making a rectangular pen for his puppy. One side of the pen is against the house, so you won't have to put fencing there. He has 64 feet of fencing. He wants to see all of it. The maximum area is 512 square feet. When you find the lengths in the area that gives it, find the lengths of the area that gives this maximum area. Okay. So let's go ahead and draw a picture. Here we got house, And then we got a rectangular kind of pen here. Okay. And then we know all the way around, so like here to here to here, this is all 64 feet. Okay. Well, let's see if you can use this information to figure out an equation that will get you that maximum area of 512. Go ahead and pause and see if you can do it. Okay. So to write out this equation, we know it's going to equal 512. So let's just start with that. That's our maximum area. We want to get 512 square feet inside here. Well, the way you get that, that's an area. Remember, area is something like base times height or length times width, something like that. So we need to figure out what's this base length here, and we need to get our height here. So we got a base and a height. Well, we don't actually have like variables right now, but we can use the fact that it's 64 feet and that as you go around, you're subtracting from that 64 feet, right? You got a big old roll, and you do one side, do another side, and you keep subtracting those from what you have left. Well, this bottom part, we can just call it X if we want to, or we could call it B for like the base, or we could take this part here, the height here, and just call it H or X or whatever. You get to pick which thing you want to represent with the variable. Let's just call this bottom one X. Well, if this bottom part is X, this part here is also X. Cool, right? These are the same. Well, if you took 64 feet and you subtracted off X here, and you got rid of that part, and you got rid of that part, what's left over here? Well, that's just going to be 64 minus these two parts here. So this part is going to be 64 minus X and minus X. You minus X twice, or you just minus 2X. Okay? So we got our base, which we're just going to call X. That's our base. And then we got our height here, which is 64 minus 2X. And now we can put them in our equation over here on the right side. The base is just X. And then the height part is 64 minus 2X. And now we have an area equation using these two bits of information that we have decided on. The base is going to be X, and we can say our height is 64 minus 2X. So we have our equation here. So that's how a lot of these problems work. You just need like, okay, this is probably an area problem. A lot of them are area problems. And how do you make an area equation when you got base times height, how long's base, how long's height, and use a variable in there to help you kind of compute those things. So there you go. Good luck on your assignment in trying to write out equations to model the rest of these.